How are we all doing, everyone? Hope you're keeping well out there. So, part 2 of the Taylor Advanced Signal Generator, the Advanced P1. And tonight we're going to look at these caps here and see about replacing them, and then sorting out the center cell rectifier. I was asked on the previous video, have I ever found one of these rectifiers that were actually good? And the answer is yes. My Taylor signal generator has the same setup, and it was okay for many years. It was only later in recent times that the rectifier fell and the HT went down, so there are good ones out there. However, if you're in here overhauling one of these generators, even if the HT is okay or thereabouts, it probably is worth your while replacing it with a diode and resistor setup, just for long term safety and reliability. What I'm doing there is I'm just winding in the variable capacitor so I don't inadvertently hit the vanes when I'm working, which wouldn't be good if I did. So what I'm going to do is I'm going to take this decoupler here, which I think is decoupling the HT, and we're going to snip him here so we can get in there just about, or maybe we can't. Alright, we'll snip him this end. Snippy snip. Snip. Right. And that quality make hunts, and it's a 0.001 capacitor. So we have our AVO meter here set on the high ohms range on there like that. So let's put the meter across it and give it the old thumbs, and we're getting a reading, so we know we're good. What's the chances the kappa be perfect? Really? No leakage at all? Stop. I find that hard to believe, but you've seen our stranger things, I suppose. Yeah, I'm gonna read in there. That cap appears perfect. Incredible. Alright, well, we'll replace it now anyway because we've no choice, but I'm going to replace the rest of them anyway. Am I going to show that work in the video? Probably not, but I'll show you the end result, and then we'll put one of the caps through a more rigorous test just to see if they are leaky. The 15 volts in this mightn't be enough to make it break down, but that's not to say that they're not. They could be okay. I have come across rare instances where caps have been okay in items like this. The moisture hasn't gotten in. I mean, it's in a coil box here and that, it's well sealed, but generally they are leaky. So this is a bit of an odd one. Now, we've replaced 3 caps in the coil box, and we're going to be leaving the coil box alone for now, moving on to the outside the coil box. There they are. None of them are showing leakage on the old AVO, which is incredible. However, at least we know they won't go bad now anyway, because they're not in there. So I will put the coil backs back together before something bad happens, not forgetting to put the valve back in first, and then we'll take her from there. Coil box back together. So working there is done. Couple of caps outside. We know these would be bad. These are always bad, so we'll lift them over. 0.04. Odd choice of value. Another one there. Looking like decoupling the HT coming in there. So we'll do a job on him too. So we'll take them out. We'll try them. As we say, we'll know they'll be leaky anyway. Now we have that decoupler replaced, and we checked it on the meter, and it is leaky. Of course, we expected it to be. Not as bad as we thought it would be. This was obviously stored most of its life in very good conditions. There's not seeing any damp. But you can see it is leaky and has to go. So we've 2 more caps to replace. Actually, no, 3. 3 more caps to replace. This one here, our HT decoupler. That one there, and I think this lad will probably give trouble as well, so we'll get rid of him too when we're at it. Right, let's see what the leakage is like on our metalmite cap. And these were pushed at the time for being really good, you know. And these are generally more leaky than most. Let's see. Whoa, yep. Let's bring that over here and let you see too how bad that down is. So, this would have been the most expensive cap put in the thing. Well, of the non-electrolytic type, and look at how leaky that is compared to these known to be crap hunts. So fairly leaky. So we'll get rid of him. 0.05. So we'll stick in a 0.056. Now, when I was changing that, I also checked the continuity in the modulation transformer, and we're looking good. So I'm hoping that the lack of AF was down to the low HT. So that's the last thing we're going to tackle. I think the smoothing can's going to be okay, so I'm not going to get too worried about that just yet. But it's time for us to concentrate our attention now on the center cell rectifier. We need to get rid of him, and we'll replace him with a suitable diode and resistor combination. Here's an odd one. Before I got too deep into the HT and that, I said I'd run it up, and I have it at 220 volts. So now the diode light looks a bit dim, and wonder what's going on. So I measured the voltage at the diode bulb, like so. I got 3.8. I said that's not enough. Measured the same on the 6J5. Then I moved it, and I'll just put my hand here. Look. It grounds through the transformer, and the transformer's loose on the front panel, which isn't great. So we'll give that a nip up. If the heater was underrun, that could have been causing some problems as well. So there you go. Something new every day. Right, well, tightening up the mains transformer has definitely solved our low heater issue. And it hasn't done anything for our low HT issue. So we still have to get into that. And then I think we'll be looking good. Now, believe it or not, 24 hours have passed since the last bit of the video you see. So I couldn't figure out why the HT was so low. And the reason why the HT was so low is because the HT is supposed to be so low. Right? The HT on this is only around 60-65 volts. So it was okay. And we appear to be working alright now. As you would see, remember when I first opened it up, that the valve base was split open. And I've said that I've found this in a lot of these octal Brymar valves, where this is it's plated brass, and it seems to be going brittle, and they're all cracking. So a couple of cable ties around it's holding everything in place quite nicely. So we'll go with that, because there's nothing wrong with the valve. The valve is working fine. The reason why we know modulation, no AF, was because the switch was dirty. So a spray on the switch put us back in business. So we're looking good here. I had this on for 4 or 5 hours today, and she drifted about, and it's set to 1 megahertz, and it drifted about 4 hertz. so we can't fall out with it at all. It's as steady as a rock. You can see there where I replaced the diode anyway, but the old selenium rectifier was okay. But because the HT is so low, there's no need for a resistor. We're quite alright without it. So all that's left to do is to put it back in its box and tidy it up, and then we'll have a look at it. See how she's working then when it's back together. Right, all back together, back in the box. A worthwhile project, I should think. So we'll switch it on and we'll see how the calibration looks. You gotta love that illuminated dial as well. Really is a beautiful thing. Now we need to make sure this is turned up all the way, because the old frequency counter isn't all that sensitive. And we're on, so we'll pick a point. Let's see, we're on the 10 to 30 megahertz band. Well, let's do this right. We'll start at the lowest. So we'll dial in 100 kilohertz on the dial here. Well, there about 100. Oh, 100, 99.9 or 100, whichever you want to call it. Let's bring the camera in a bit closer here so we can see the dial. That looks like 100 there, and that is 100. So that's quite good. So we'll go up the other end of that. Tell you what, we'll try and bring the camera in on the stand a bit better so we can see it. That's a better vantage point, I think. Right, let's go the other end. Let's go 250, let's say. Line up on 250 on the clock. 249. And if I put that so the counter reads 250, it's sort of half the width of the cursor away from it. I mean, that's well within spec. It's 1%. So we'll go up the next one, which would be 300 to 1000. And we'll go down to 300. We'll line it up on 300. 300. 299. And again, if we get it so the counter that says 300, I mean, it's the width of the cursor and that's all. Around the halfway mark, 550. 549. Yeah, I mean this thing is really spot on. 1000. Yeah, right there. Again, just the width of the cursor up, so it's spot on. It wouldn't be much better than this. You must remember, this isn't a laboratory grade instrument either. You know, so. Next range up, 1 megahertz. Line that up. 1 megahertz again. Spot on. And it's right on the cursor there for 1 megahertz. Halfway, 1500. Let's see. Right on. Yeah, it's bang on there. 3 megahertz. Yeah, a little bit there. Fractionally out on 3 megahertz. Next range up. Start at 3. This is the 3 to 10 megahertz range. 3 lined up. 3 spot on. Halfway, which would be around 5.5. Again, spot on. What a wonderful instrument to have held its calibration so well all those years. 10 megahertz. Fractionally out on the cursor. Fractionally out. Next range, we're nearly there. This horrible video is nearly over. 10 megahertz. Yep. That's spot on. Absolutely spot on. $20 megahertz. Halfway. Bang on. Absolutely spot on. 30. Yeah, it's right there. This is an incredible bill of kit. Next one up, last range. Let's go for 30 megahertz there. Not too far out. Let's set it so the counter reads 30. Fractionally out. And only fractionally out. Right, we have to go up the range on this. Set 50. Remember, it's 1%, so it's well within. That's spot on. We're well within tolerance here. 100 megahertz. It really is like 100 megahertz out an instrument for this. For it to be spot on, I mean, it's shooting well above its weight, really. That's bang on. Bang on. We couldn't fall out with that. The last thing to do is we'll just listen to the modulation on the FM band there. Right up to 100. Let's see if we can hear it. Let's stick a piece of wire in this and see if we can hear it on the radio. What a beautiful tone. Dial's bang on 100 on the old stereo. And this is bang on 100. I think we'll call that a success. I am happy with that. One more job to do with this. I might put this into service actually, because I think I like it a little bit more than my Taylor. And then the old leader, well, I mean, if I put the two side by side, you can tell the difference in quality straight away. This thing leaks RF like a sieve, and yeah, it hasn't got a calibrated output like this one. Only thing this has going for it over that is it has external modulation on it, so I have used this as a pantry transmitter once or twice. No, I know. But no, really happy with this. Big thank you to Joe Malloy for the donation, and it's going to be a valued piece of test equipment here in the workshop. Next thing to do, if I'm going to use it, is to make up a dummy aerial for it. which we'll probably make a video on that somewhere down the road. Okay, thanks for watching, and I'll catch you in the next one. Good luck for now. Bye bye.